Well, good morning to Thursday, which is kind of like our Friday because we don't have anything assigned tomorrow since it's Good Friday. Hopefully you got my message on Parent Square. I got everything graded from last week and 2 thumbs up. You guys did a fantastic job. Everything was just consistent. It looked exactly like it would had you been here in class. Everything was turned in and organized, and you guys just did a fantastic job. And your hard work, I can tell you're engaged and really taking your work seriously. Your grades prove that. I just am so proud of you guys. So keep up the good work. And hopefully the rest of the year will, if we have to do this for the rest of the year, you'll just stay on track like this. I mean, it's poised. You guys are poised to just really do well because that first week you guys have just adapted so well and have risen to the challenges that have been put before you and are doing a great job. So I have no doubt that if we have to do this for the rest of the year, then you guys are just going to do fantastic and really end the year well. And I don't want you to think that that it's just because we've eased up on you or that we've just kind of set back and are taking it easy. We're doing things exactly like we would do if you guys were here in the classroom. So you genuinely are doing a good job. It's not because of us lightening your load or anything like that. You're maintaining the load and you're adjusting to the challenges, and you're just doing a great job. So I just want to commend you on that. I do want to clarify something about yesterday's work. It was an assignment that we all did together, and I did put on the board, this is just a freebie, but let me just make it clear that you had to have gone through the work and put it on paper, and you still have to turn it in. So you're not just going to get that free 100 just for doing nothing. You had to have gone through the steps with me and done the work on paper and turn it in just like a regular assignment. You just should by all means make 100 because we did them all together. So I just wanted to clarify that. I still expect to see it. It still should be in the packet that you turn in on Monday, okay? So today's lesson, we are on page 390. We're at the bottom of page 390. And this, it doesn't matter where you are in your math career, this should be very familiar to you. We're going to be working with the Pythagorean theorem today. So the way that you have it in your book looks like this. Okay. So the Pythagorean theorem is used specifically on right triangles. Okay, that's something that you have to remember. That would be like a potential quiz question. Okay. They only apply, we only use them on right triangles. So, in this right triangle, C is the hypotenuse. That's the longest side that's opposite the right angle. Okay, we've been talking about that for days now. The other 2 guys we just call legs, okay? And it doesn't matter. It doesn't matter if I call this A and B or if I call this A and B, okay? A and B don't matter. They're just the legs. The formula for the Pythagorean theorem is a squared plus b squared equals c squared. So as you are plugging numbers into the Pythagorean theorem, your A and B don't matter, okay? C is the one that matters. C has to be the hypotenuse, okay? So the hypotenuse has to get plugged in for C. I think that pretty much summarizes everything at the bottom of that page. So let's just dive in and start using it. So what we would use this for is if I had two sides, any two sides of a right triangle, and I needed to find the third side, that unknown side, I would always use the Pythagorean theorem in order to find it. Later, like in geometry, you have other options, other ways to find it, but you know, the Pythagorean theorem is it's kind of a go-to. You know, it's always available to you on a right triangle. So on the next page, on page 391, at the top of the page, we're going to be going through example 8.2b. So the directions say, find the missing side of the right triangle. So this is, I'm just going to use this one. So these are the measurements that are given to you. You're given A, you're given B, and we're looking for C, okay? So it's just a matter of substitution. So for A, I'm going to plug in a 5. So it's going to be 5 squared. And then there's that plus sign. And then I know B. B is 9. So it's 9 squared. And I don't know C. That's my unknown, so it's going to stay C. Okay? So then I just do the math. 5 squared means 5 times 5. It does not mean 5 times 2, remember? So 5 squared is 5 times 5, so that's 25, plus 9 squared is 81. So I combine these like terms here, and that equals 106. So, but you're not done, because we need to know what C is, not what C squared is. So to undo a square, we do square root. So we have to square root both sides. And I did not bring a calculator. So you would punch this into your calculator. Your calculator would simplify the radical for you to see if there are any perfect squares that can pull out. Apparently there's not. Okay, so this would be plus or minus the square root of 106. However, we would only use the positive because links are always positive, always. Okay, so you just kind of throw out the negative. So you don't even have to worry about that. You just know that links are always positive. So this would equal the square root of 106. So, and you could check it. You could just plug, so now that I have all three sides, you could plug it into here and check it. So let me just show you what you would do. So you'd plug 5 in, and then B, you'd plug in 9 for B, and then this would be the square root of 106 squared. This would be 25, 81. So the square root of 106 squared, you know, is 106. The square root and the square just undo each other. And then you add these. That is a true statement, so you know that you got it right. Right? Everybody following along? Any questions popping up? So we'll go over the next one. That one is going to require a little transposing, so I want to be sure to go over the next example as well. So that triangle looks like this. Okay, so you always start with your formula. A squared plus b squared equals c squared. You still have that memorized. And then we just substitute in the things that we know, okay? So I don't know a, so he's just going to stay in a squared. And then b is 3, so I want to plug 3 in here. C is 8, so I'm going to substitute 8 in here. So a squared stays in a squared. 3 squared is 9. 8 squared is 64. All right? So now this is just basic algebra. To get, we're trying to solve for a. And so we have a couple things that we have to do to get it by itself. We know that we have this other term over here with it that's got to go. And we know that we have an exponent that's got to go. So the first thing that we have to do is isolate the term that a is in. So we want to take the 9, we want to move him over and make him negative. So that guy's going to stay on the left side. We're going to take the 9. When he moves over, he changes signs and becomes negative. I'm thinking that's 55. Is that right? Yes. Okay. All right. So now we're one step away from getting a by himself. So I need to know what a is, not a squared. So to undo a square, I square root. So a equals the square root of 55, and your calculator will simplify that for you if it happens to have a perfect square in it. And then you don't have to worry about the plus or minus. We don't ever use the negative for a length. Again, lengths are always positive. Okay? So you can always check it too. So I'm thinking that a is the square root of 55. So the square root of 55 squared plus b is 3. And then c is 8. So the square root of 55 squared is 55. The square just takes the radical away. 3 squared is 9. 8 squared is 64. 9 and 5 is 14. So that is true. That's a true statement. So yes, I know, in fact, that my answer is correct. So are there any questions about this? This is probably nothing new. So the next section is pretty lengthy and pretty in-depth, and we don't have time to go that deep into it, so we're just going to call it a day here. And your assignment is 8.2b, numbers 7 through 12 on page 394. I want you to draw your triangles and show all of your work. There aren't that many problems, so it shouldn't be too daunting of a task for you to be able to show me all of your work. So like this is what I want to see on every one of your problems. And again, there aren't that many, so. Any questions popping? If you guys are good, we're going to call it a day. If you were in class, I'd just let you work on this assignment, so. If you guys are good, you'll be able to knock this out pretty quick this morning and enjoy your 3-day weekend. Get outside, get some sunshine today or tomorrow, because I think rain is coming. But
Ryan is asking you to do number 7 with me.
I just did too, just like it. Number 7 was just like the first one that I did. What's so different about it? Like, is there something in there that you see as different? You've got A and B, you're just looking for C. Come on, Ryan. Talk to me, Ryan. On the first one?
No.
So wait, what was the question?
He said instead can zoom in on the whiteboard.
Oh, okay. So the only thing that's different, so I will say this, the only thing that's different about the problems is that A and B aren't labeled. And it doesn't matter, okay? So I'll help you set up number 7. How about that? I'll help you set it up, but I'm not going to work it all the way through. So hopefully everybody's done with this, because I'm going to erase it. No, that's true. That's true. Okay, so number 7. Okay, so this is what it looks like. So I guess this could be a little confusing. Okay, so for whatever reason, I don't know why, there's a theta down here in one of these angles that doesn't matter. Like this, I don't know why this is here. It doesn't need to be there because we're not doing anything. The Pythagorean theorem doesn't need a reference angle. So just ignore that, okay? So if that was throwing you for a loop, just throw it out, disregard it, okay? So these are the two sides that have been given, okay? And so I know that I'm looking for the hypotenuse, which is C. So these are A and B. And again, it doesn't matter if you call this A, if you substitute this in for A and this B, or this is A and this is B, it doesn't matter, okay? So you could do 14 squared plus 8 squared equals C squared, and call this A and this B, or you can do this. It doesn't matter. You're going to get the same thing. A and B don't matter, okay? And this, you don't even need to, it doesn't need to be there. Again, I don't know why it's there. We're not doing trig functions. I don't know if it's there just to kind of get you used to looking at it. I don't know, but you don't need it. And then on, so let's talk about what it'll look like on a situation like number 9 maybe, that looks like this. We know this and this, right? And then for whatever reason, we've got a theta down here on this acute angle, which really, again, it doesn't matter. Doesn't matter. Okay, so in this scenario, when I go to substitute values in for A, B, and C, okay, C has to be the hypotenuse, right? So that is this guy, 12. So I know he goes there. It's going to be 12 squared. Now, it doesn't matter if you plug 6 in for A and solve for B, or if you do it the other way. It doesn't, A and B don't matter, okay? So you could call this A, or you could call it B. You're going to get the same thing either way, okay? So qualifying who is A and who is B isn't necessary. Doesn't matter. Does that help? Make sure that you check your answers. You have the ability to check your answers, and you will know if they're right or wrong, so check. Everybody's good? Okay, awesome. Just plug in your answers and see if it's true. That's all you have to do. Okay? All right. Well, then I'm just going to cut you loose and let you have it. We'll dig in deeper using both. So what we'll do next week is we'll pair the Pythagorean theorem with trig functions into some problems and do them, utilize all of them, okay? So we'll get a little deeper, but we just don't have time to do it today. So let's call it a day. Let's call it a week. All right? I guess we're done. Let me know. You can always message me through Parent Square if you have any questions. So I'll be out and about, but I'll be checking my phone between mowings. All right. You'll have a good weekend.